This is another attack that I've come up with. This particular industrial process is called the two-pipe system, or reactor. As you can see, there's an analog pressure gauge over here. There is a digital pressure gauge over here, which feeds back into the PLC, which is again a Simatic S7-1200 PLC, and it's all Siemens hardware. That's the air compressor. So it pressurizes this pipeline. Now you can see it has two set points. It's got an upper set point and it's got a lower set point. The upper set point is set to 40 psi, and the lower set point is set to 35 psi. Basically, when I start this thing, the pressure in the valves and the pipes should start rising when it hits 40 psi. This solenoid should open to bleed the air, and the pressure should drop back down to 30 psi, and then the solenoid should close. 35 psi, the solenoid should close, and the pressure should rise back up again. So it has to maintain the correct pressure. So let's start this. Compressor's coming on, air pressure is rising, and that's hit 40. I'm gonna bleed the air a little bit so that we can see it doing this rapidly. So 40 and 35. So you can hear the solenoid clicking on and off, and there's air bleeding out of it, and the system is maintaining control. And this is what the graph looks like. So it's sort of a very poor sine wave at times. And here I have another attack where I will attempt to stall the solenoid. So it should not be able to bleed its air pressure. So start. Solenoid stuck. Air pressure is stuck, and that's not how an industrial process is supposed to work. Better shut the thing down. Stuck, stalled at 35 psi, 36 psi. Let's stop the attack, see what it does. Let's open up the bleed pressure a little bit. Going up to 40. And let's start the attack again when it hits 40. And it's stuck. It'll never reach its upper set point. Even if we close this, we're overriding it and we're telling it never to go up to 40 psi. And it shuts off because it's a safety mechanism. Obviously, they don't want to blow students up.